Hi everyone, welcome to my channel Design with Roosevelt. One of the goals of this channel is to review and provide solutions for CSWA practice problems. I recently uploaded solutions for all the questions in section 1. In this new series of videos, we'll be working on questions in section 2 of the problem set. Today we'll focus on question 2.1. Let's take a look at this question. So in this question, unit of measurement is millimeter gram second. Like always, when we start working in SolidWorks environment, we need to ensure we are using the same unit of measurement. Now, looking at this geometry, you can see the top view here. And by looking at this top view, you can see that we have a symmetric geometry. Basically, what we have here is we have horizontal symmetry line and we also have vertical symmetry line. My approach to solve this question is to first work on the overall geometry and ignoring these two holes that we see here. We can always add them at the end. So what I'm going to do, I'm going to make the 2D sketch of the overall geometry, use extruded bus feature to make it, and at the end I'm going to make these two holes. So with this introduction, let's go to SolidWorks and start modeling this part. In SolidWorks, first things first, we need to check unit of measurement, and you can see in the right corner that we have a correct unit of measurement, which is millimeter gram second. Now to start modeling this part, I'm going to click on a sketch and then I'm going to choose a sketch command, and here I choose top plane. Now because this geometry is symmetric, what I plan to do is to focus only on a quarter of the geometry. We can make a 2D sketch of the quarter of the geometry and then use mirror feature to make the final model. So let's do that. In order to do this, from the sketch tab, I'm going to click on line command, and then here I'm going to make this line first. Now we need some sort of arc shape in a corner. So now what I'm going to do, I'm going to click on the sketch tab and I'm going to choose arc command. I click here and then this is my arc. And last step is to make another line. So I make another line and that's it. Okay. Now we have the 2D sketch, which is kind of showing a quarter of the geometry. Let's add some dimension and constraint to this. First of all, I know that this point should be always on the horizontal line with the origin of the geometry. So what I'm going to do, I click on this point, hold Control, and I click on origin of the geometry. And from the options I have, I'm going to choose vertical constraint. I repeat this process for this point. I click on a point, hold Control, I click on origin of the geometry, and from the constraint I have, I'm going to choose horizontal. Now, we know that the overall width of the geometry is 109 millimeter. So what I'm going to do, I click on a smart dimension, I choose this right edge, and I choose this point, and this distance should be 109 millimeter divided by 2, because this is only half of the geometry. And I'm repeating this process for the height of the geometry. We know that the overall height of the geometry is 31 millimeter. So I click on this top line, I click on this point, and this distance should be 31 divided by 2 millimeter. Okay, awesome. Now you can see that the arc shape that we have is not fully defined, of course, because we didn't add a radius to this arc. So looking at the top view, you can see that the radius of the arc should be 9 millimeter. So I click on the arc, and then here for the radius, I'm going to choose 9 millimeter. Okay, awesome. Now you can see that even though that we added the radius of the curve, we still don't see a fully defined geometry here. So let's go and check the 2D sketch that we have and see if we can find any sort of other constraint in this geometry. As you can see, in the top view, we can see that we have a plus sign here. This plus sign shows the center point of the arc. And you can see that this center point is kind of in line with the horizontal and vertical edge. So that's the constraint that we are looking for. You can see this is a horizontal line showing that the center point is in line with the top edge of the geometry. So let's apply this constraint to our geometry. To do this, I can select center point of the arc, hold Control, and I select the top line, and then here I'm going to choose a coincident constraint. And now you can see the geometry is fully black, which means that it's fully defined. Now we know that we don't want to have the sharp corners here, and according to the 2D sketch, we have 3.75 millimeter radius in those corners. So what I'm going to do, I'm going to use a fillet command to make the fillet in those corners. So to do this, from the Sketch tab, select Fillet command. And then here, the radius that we want should be 3.75 millimeter. And then I'm going to choose this corner and this corner. And then you can click on OK. Awesome. So now we have our geometry here. Okay, so now we modeled a fully defined geometry for a quarter of our geometry. We are ready to use mirror command to make a full geometry. To do this, first of all, we need a mirror lines. So what we can do, from a Sketch tab, we can click on line and choose center line. And I'm going to make two reference line here. This is the first one, and this is the second one. Now let's use mirror command. To do this, from the Sketch tab, simply choose mirror command from here. And now we have two sections. First, we need to choose entities that we want to mirror. And to do this, I select this line, this one, this one, and this one. And then we need to select the mirror line. And to do this, I'm going to choose this vertical line. And then click on OK. So now we have half of geometry modeled. Let's repeat this mirror command one more time. So to do this, from a Sketch tab, I click on Mirror Entities. You don't need to select all these points one by one. What you can do, you can select all of these points. And now you see all these lines are selected. What I'm going to do, I click on the second tab here, and then I'm going to choose horizontal line as my mirror line. And then you can see the preview here with yellow color. Click on OK, and that's your final 2D sketch. Okay, so now we have our 2D sketch. The next step is to use offset command, because we know that we have consistent 1.5 millimeter wall thickness around the geometry. So what I'm going to do, I'm going to make that wall thickness with a offset command. To do this, we click on the Sketch tab, and then here we can click on Offset Entities. For the distance, you can simply choose 1.5 millimeter. And then make sure Select Chain is selected, because it makes your work much easier. Now, when I click on one of these lines, you can see that SolidWorks automatically selected all the lines like a chain, and you can see the preview of the offset line with a yellow color. We know that we want offset line to be in the opposite direction. So what I can do, from these options, I can select on reverse, and now you can see the preview of the new offset lines. Click on OK, and now we have the offset lines ready. Okay, so now we have the backbone of the geometry. We are ready to use extruded bus feature to make the 3D model. So let's do that. To do this, we can click on Feature tab, and then we can choose Extruded Bus. And here, click on Select Contours, and I'm going to select everything basically here. I'm going to select this one, I'm going to select this one, and everything is basically selected. Now, the question is, what's the thickness that we want here? For the overall thickness, we need 1.5 millimeter thickness for the geometry. So what I'm going to do, I'm going to click here and I choose 1.5 millimeter thickness. And I hit enter. Okay, so now I have the main body of the geometry modeled with 1.5 millimeter thickness. Now if we remember, we modeled an offset 2D sketch because we wanted to make the edge of the geometry. So let's click on extruded bus again, and then from the model tree, I click on the model tree. I'm activating the previous sketch again. This time, I only select the corners, like here, this contour. And we know that in addition to 1.5 millimeter thickness, we need 1.5 millimeter more because the overall height of the edge is 3 millimeters. So what I'm going to do, I click here and I choose 3 millimeter and I hit enter. Now you can see that we made the edge of the geometry. So that's the main body, and this is the edge with 1.5 millimeter thickness. Okay, awesome. So now we have everything. The main body of the geometry is modeled. It's time to make 2 holes and 2 buses that we have on the geometry. To do this, I click on a sketch. I click on a sketch command, and because I want to make my model here on this surface, I select this surface. Now what we can do, we can click on circle command, and then here I'm gonna make 1 circle and second one. Now looking at the top view, we know that the diameter of the inner circle should be 5 millimeter and diameter of the outer circle should be 8 millimeter. Also, we know that the distance between center point of the circle and the left edge should be 9 millimeter. And finally, we know that the center point of the circle and origin of geometry should be aligned. So I'm going to choose horizontal constraint. And now we have fully defined geometry. So first step, I'm going to use extruded cut feature to make the hole, and then I'm going to use extruded bus feature to make the buses. So what I'm going to do, I click on feature tab, I choose extruded cut, and here you see from the contours, I only select the middle one. And from the options that we have here, let's choose through all both direction. This means that the cutout will go through the geometry in both directions. And then I click on OK. So now I have the hole. Let's make the bus. To do this, I click on extruded bus, I click on model tree, I click on extruded cut, and I activate previous sketch. And what I can do here, I can simply select the ring that you see here. Okay. So for the ring, we know that the height of the bus in every direction should be 0.75 millimeter from the surface. So in this direction that we see, I'm going to choose 0.75 millimeter. And that's what I get. But this is only going in one direction. What about other direction? So what I can do, I can click and activate direction 2. And now you can see we have a second direction. If you look at the geometry, this distance from the top surface to the surface of the bus should be 2.25 millimeter. So what I can do, I can choose here 2.25 millimeter. And now this is a preview of the bus. I click on OK, and that's it. If you have doubt in exam, you can quickly click on evaluate, choose measure, and then you can select this surface, hold control, select this surface, and you can see the distance is 0.75 millimeters. So that's the correct distance we want. Now, we made the bus and the hole on one side. Let's make it on the other side. To do this, I'm going to use mirror feature. So let's click on feature command. And then here from the options that I have, I can choose mirror command. Okay. So the first thing that we need to select here is the mirror plane. So what I'm going to do, I'm going to click on right plane. And then I click on feature to mirror. And what I can do here, I can select bus extrude and also cut extrude because we want both of those features to be selected for the mirror command. So now you can see the preview here. You can click on OK, and that's it. You can see this is the final geometry with the buses. Okay, awesome. So I think that's pretty much it. So the next step is to check the total volume in the question and compare it with the total volume we have here in our SolidWorks model, and then see if we have the right answer or not. Let's go to the question and check the total volume. In the question, you can see the total volume is 5,263 cubic millimeters. Let's go back to SolidWorks and check the number. In SolidWorks, in order to find the total volume, you can click on Evaluate tab, and then we have the mass properties. Click on it, and you can see the total volume here. The total volume that we have in our model is 5,262.8. If you round up this number, you will exactly get the same answer as shown in the main question. So we can claim that our geometry is correct and we found the correct answer. Okay, that's it for today. I hope you found this video helpful. If you have any question or feedback, feel free to drop a comment down below. Thanks again for watching. My name is Rusbe, and I'll see you again in the next videos.